Hello, everyone. Welcome to the fourth Zcash Show Tell event. This series is about highlighting various projects in the Zcash community and overall ecosystem. So today's presentation comes from two Zcash Company engineers, Jay Graber and Ariel Gabizon, who have been working on diligently implementing a version of XCAT for which is also known as cross-chain atomic trades. And this implementation is using Zcash and Bitcoin blockchains. So feel free to post questions in the chat box, which is next to the live stream YouTube screen, or you can follow up afterwards with Ariel and Jay in the Zcash community chat, which is linked in the description. So now I'll just hand it over to Jay and Ariel to start the presentation.
All right, so we're going to start with like a few slides to explain theoretically how the atomic trade works, and then we're going to have a live demo. So Jay, did you want to say something before the slides, or?
I guess just an overview of what we're going to do. So yeah, after the slides, we're going to go through a demo of what we've built, which is basically just a small command line tool for executing a cross-chain swap. That's what the acronym XCAT stands for. It's a cross-chain atomic trade or transaction. So yeah, after that demo, we'll show you the trade on testnet on the Bitcoin and the Zcash explorers, and then open up for questions.
Yeah, okay. So, right, so let me share my slides. So atomic trades, what's the basic idea? So suppose Alice has some Zcash and Bob has some Bitcoin, and they want to exchange it in a way that's, first of all, trustless. So that means, for example, there won't be a situation where Bob will get Alice's Zcash, but will keep his Bitcoin to himself. So, and also without the aid of a third party. So, right, usually how do we do these things? Well, basically, we'll all put our money in an exchange and then trust the exchange to distribute the funds as we intended them to be distributed, right? So at atomic trades, the idea is how can we do this without a third party and without needing to trust each other. All right, so the basic tool that enables this is something that's called hash time block contracts. So this is a very important primitive. It's also, for example, what enables the Lightning Network to work, if you've heard of it. So what's a hash time block contract? So the idea is that Alice is going to lock some of her coins in this contract. And this contract will have in it published some hash value. And now how the contract works is that if Bob at some point will publish the pre-image of the hash, then that will enable him to take the coins that are in the contract. On the other hand, say a certain amount of time we've set in advance has passed, say we agreed on 24 hours. If that time has passed and Bob has not retrieved the coins yet, then after that time has passed, Alice can take back her coins. So this is what's called a hash time block contract. And the point is, right, contracts, you usually think Ethereum. So this primitive is something you can do both in Bitcoin and in Zcash, which has the Bitcoin scripting language. So it is something we can have in any cryptocurrency that has the Bitcoin scripting language. All right, so now the question is, how do we do such an atomic trade using these types of contracts? So the idea is that Alice will choose some secret X And then she will put her, say, Zcash coins in the contract and publish the hash of X in the contract. So, right, so only she knows X. Okay, now Bob sees that Alice has locked her Zcash in this way. So he's going to lock his Bitcoin with the same hash value. All right, now Bob has locked his Bitcoin with the hash of X. So Alice knows X, right? She chose it. So now she's going to publish X on the Bitcoin blockchain. And that will enable her to take Bob's Bitcoin, right? Because that's how the hash time block contract works. All right. And now Alice has published X. So X, everybody knows X. It's on the Bitcoin blockchain. So in particular, Bob now has seen X. So he can use X and publish it now on the Zcash blockchain and take Alice's Zcash for himself. Okay, but of course, one thing is, all right, say after Bob locks his Bitcoin, for example, Alice just aborts. Right? Then no problem, because we have the time block. So after say 24 hours will pass, Bob can just take back his Bitcoin. So this is where the name Atomic is from, that either both trades will happen, both the Bitcoin and Zcash will move sides, or neither. All right, so that's the basic idea. And now we're going to show you an implementation of this protocol. Unless there are some questions or
no, let's just go through it and then let's do questions at the end. I feel like that would be easier.
Okay.
Okay.
Okay, good.
Yeah, so I'm going to go ahead and screen share here. Let's see. All right.
Okay, I'll also screen share.
Okay, so what we decided to build was really just the simplest tool. It's a command line tool that requires you to be running a Bitcoin full node and a Zcash full node in order to use in this implementation. So there are definitely ways to do it without running full nodes, and we're working on those implementations, but this is just the simplest thing. So right now, this is a Python package that you can install, still in kind of a demo form, but I'm going to use this to initiate a new atomic trade. I'll use my tool XCAT and start a new trade that I'm going to call Ariel because I'm trading with him. Okay, so if I click through this, it'll just generate the coin addresses for me based on my local nodes that I'm running. So I enter addresses. It's going to default there. I set that up earlier. And then there, I went through and put in my addresses, put in his addresses. I put in the amounts we wanted to sell and the amount I wanted to receive in exchange. And then this kind of all got formulated into a pay to script hash address and redeem script. And then all of that information is stored in this kind of JSON object right here. And so what I'm going to do now is send all of this information over to Ariel, which he can import and check out and see if he's going to agree to the terms of the trade. So basically, in order to start one of these, you have to have established prior communication with the other party, and you need their addresses on both chains, and you need to have the amounts you're going to trade and the kind of exchange rate for that decided out of band. So assuming all that's good, and I have some other channel of communication with Ariel, like we do right now, I'm just going to send him this information. So now I can do XCAT export trade. And when I export the trade here, it's going to give me the hex string, which is this serialized object. So that which he can import, but it's kind of a long hex string, and so instead of sending it to him directly, I'm going to use a little tool called Magic Wormhole. So there's an option in here for using Magic Wormhole to send this information over to him, rather than me like sending this hex string to him manually. So rather than like copying or pasting this to him, I'm just going to send it through the wormhole. This is a tool you'll have to install separately, but it's available through like the apt repository for Linux, and you can also use pip. All right, so starting this transfer. Okay, Ariel, now you're going to have to do XCAT wormhole import trade, and then I can give you the code.
All right, so just to clarify a little, right, so far no trade has happened. We're just kind of setting green on what our addresses are, what the amounts are. And right, one thing to notice is that each of us needs both a Bitcoin and Zcash address, right? Because of this thing that if something will go wrong in the middle, we need a way to refund, right? Like Jay wants to give her Zcash to me. If like I abort or something happens, she needs a way to get the address refund, the Zcash refunded. So that's why each of us has both a Bitcoin and Zcash address. So anyway, so now I'm going to import the details of the trade. Right, so now I need the wormhole code. So
So the code is, yeah, 3 ultimate reform. Right. So I'll call it also Ariel. Okay, so now I've gotten the trade details. So Jay is the initiator. I'm the fulfiller. And I'm looking at the addresses, the amounts. And if it looks okay to me, I just say to Jay, all right, this trade looks all right to me. You can start the process. You can fund your Zcash address, the Zcash HTLC. You can now create that. I think we started with Bitcoin this time, but. Oh, so you're doing you're selling Bitcoin? Yeah. Let's see. Hang on. So what I'm going to do to check is you're selling Bitcoin. Yeah. What I'm going to do to check this trade is just enter the command check trade for my XCAT tool, and that's going to look up my trade I have with Ariel and see what the status is and like what I can do. All right, so it has scanned the blockchains, found these pay to script hashes, seen that they're both empty, and that to initiate, I need to authorize it to send funds. So I just hit enter and authorized it. So that sent this funding transaction to this pay to script hash. And that meant that I have initiated the trade by putting the Bitcoin I intend to sell in the pay to script hash where I intend to sell it and give it to Ariel. Great, so now that's on the blockchain. If we went to a testnet explorer, we'd be able to see this, but we'll show you the more like interesting ones later. All right. So just for anyone who may not know, pay to script hash is like a special Bitcoin address or Zcash address that lets you do these more sophisticated transactions, like with these HTLCs we saw in the slides. All right, so Jay has funded her HTLC, and now I'm going to check that I'm going to check what the status is. So right, so I see that yeah, she's really funded her side. So yeah, so I'm gonna fund my side too. Right, so this is the transaction that I'm funding my HTLC. Right, so you can see it. Should we show it now in the Explorer or? Yeah, sure, if you want to. Basically, at this point, there's these are just funded and waiting for some other action to be taken. So these pay to script hash addresses contain conditions in which you're only going to be able to withdraw the funds if you meet the conditions. And so because of the timeout period, if we do it within the timeout, the party that wants to receive the funds will meet the condition and can withdraw it dependent on releasing the secrets. And then if it times out, the party who initiated it can just refund it to themselves. So right now we're well within the timeout period because we're just coordinating and intending this trade to go through. So in this next step, which I do, I'm going to be redeeming it. Oh, you want to show it on the Explorer?
Yeah. Right. So this is like my fund transaction. Right. This is where I've locked my Zcash with a hash value, like we saw on the slide. So this is the address where the Zcash is locked. Okay.
Okay. So now this is the step where I'm going to redeem. So there's no different command. I just basically check the trade again and see what needs to be done. All right, it looks like I can definitely redeem this. So it checked the pay to script hash. It saw that my side was funded, his side was funded, detected the status of this trade, and then it retrieved the secret for me, which because I'm the initiator and I'm the possessor of the secret, it's just saved locally on the computer. So this secret right here is not on the blockchain before I redeemed it. It was just stored locally. But then I hit enter to redeem it from this pay to script hash. And as soon as I redeemed this secret that I had was used in the redemption. And now that should be on the blockchain available for Ariel to use to redeem his
Right.
portion.
And so here you can see that like this address where I sent my Zcash, you can see the Jay's redeem transaction. So this is where she took my Zcash, basically. Okay. So now the thing is, like as we saw in the slides, while she took my Zcash, she had to publish this hash pre-image that she chose. So when I check the trade now, right, then I scan the blockchain. I see she's redeemed. She's taken my Zcash, and while she's done that, she in the what's called the script sig of the transaction, she had to write the hash pre-image, the secret. So now I could use this pre-image to redeem her Zcash, right, which was locked with the same. Redeem her Bitcoin, which was locked with the same hash value. And this is what I did. And to get a sense of how this works on the most technical level, let's look at the Bitcoin block explorer. Let's look at this transaction where I've taken Jay's Bitcoin, and here you can see kind of technically how it works. So here I wrote down the hash pre-image that I took from her redeem transaction, and here is the script that the Bitcoin was locked with, right? So basically. Right, you see how this works. That you write the hash pre-image, and here you have the opcode of the hash function, and basically, right, how it works in Bitcoin or Zcash is if all this thing is a program, it evaluates to true, then the transaction is valid, and it evaluates to true because this thing is really the pre-image of this thing under SHA-256. Okay, so.
Awesome, yeah. So then we've completed an atomic swap between Zcash and Bitcoin on the testnet blockchain, and showed you kind of how it worked and what our version of this depends on. Really, the tricky part for this is running your own Bitcoin and Zcash nodes that are fully synced, and so eliminating that dependency is kind of a next step for us. And yeah, I think that concludes this portion of the presentation. We could take some questions.
Mm-hmm.
Cool. Thanks for the demo. That was really cool to see. So there's at least a handful of questions in the chat. So the first one I see is, what is the execution time of the trade? Does it require X number of confirmations on the blockchain? Is there mutual trust between the chains?
Right. So yeah, we do need to have, we need to determine what is the best number of kind of confirmations to wait. And I think that's like a configurable field, kind of like the number of minimum confirmations you want to wait for to like accept funds. But obviously for the purpose of this demo, we wanted to move through it really quickly. So we were just sending and spending without any minimum confirmations.
Yeah, so basically it's the same, it's exactly the same as in any other transaction. If you wait X confirmations, you have X level of certainty.
Yeah, and I guess part of what this question gets at is also the difference in block times between like Bitcoin and Zcash. And so like kind of calculating like the average like block time and watching how fast that's proceeding is definitely a part of like making this secure, because you need to have the timeouts be synced with the block times, and like yeah, mostly it works out because you know the average block time and they don't get too far out of sync for like the main blockchains.
Thanks. And I think a follow-up question to that is kind of based on how people will kind of manage the value fluctuations between two different currencies. Like since kind of the values in cryptocurrencies tends to be volatile in a lot of situations, do you think that this kind of transaction will happen fast enough where that won't really impact the value of the trade?
I mean, I think because this is a pretty like user interface agnostic implementation, it really is going to be up to whatever sort of agreements or interface is put over this to like determine what the exchange rate is going to be and what users will agree to. Like the nature of this atomic swap is that there is the risk of your trade taking longer than you expected. And if like this isn't like a decentralized exchange or something, which I assume runs into these problems, like they would have to figure that out. This like would only work if you and the other user have kind of agreed on the conditions, agreed on the exchange rate, and are just okay with, you know, the inherent volatility that's going to happen in the few minutes it's going to take you to do the trade.
Third question, how does this differ from Ripple Interledger Protocol for distribution between currencies and cryptocurrencies?
I mean, that's Ripple's Interledger is like a whole system, basically. And this is kind of like a very basic primitive. So I would say this is more just like, I would think of it more as like a tool which is the simplest thing, like the simplest version of a cross-chain swap. And you use hash time locks to move money across chains in Interledger and in the Lightning Network. And a lot of implementations, like this is a really useful primitive. But as far as I know, I didn't find like a super easy implementation already out there for just two people who want to arrange all the stuff out of band. So that's kind of what this is targeting.
Yeah, I don't know too much about those protocols, but maybe an advantage here is you just need some Python scripts. You don't need another structure from another chain or another. You just need to download some Python scripts and that's it.
But yeah, it's like a Python package that you could install.
Mm-hmm.
Yeah, and I think there's a lot more going on with like larger systems that use these primitives to build up entire networks of kind of different value flows, and we didn't concern ourselves with any of that. If other people should build that, it'd be great.
Mm-hmm.
So the next question, it's asking about creating a UI or API, but maybe that sort of just touches on the general roadmap for XCAT. Any insight you can provide on that?
Yeah, we're trying to make this tool really useful in terms of something that can be included into other applications. We still have some work to do to make it really useful for different kinds of use cases, but ideally the goal would be to build something that other people could build UIs for and kind of use this to just construct the scripts and do that part of the trade. So we've been trying to like make it as modular as possible. We don't necessarily plan to make a UI on top of this. I could imagine something that where you have a website where you can arrange trades and like execute cross-chain swaps with people. But yeah, I think we decided that creating a whole system like that was somewhat beyond the scope of what we wanted to create.
Yeah, I'm much more, I mean, except the fact that it's less work, I'm more enthusiastic about kind of the possibility that you have this really basic API and, you know, anyone can integrate it in however way he sees. If it's an exchange, they can use it somehow. If it's, I don't know, Shapeshift, they can use it somehow.
Yeah, also because there's a lot of design choices with how you would want to do a UI for this. Like, how would you handle things like the exchange rate fluctuating? Like, there's different trade-offs you could make there. And I think it would be good for different implementations to exist for something like that. But one of the tricky parts in working with Bitcoin scripts is just constructing the scripts and getting that part to work right, because you can't really do it through the like wallet command line interface. And so figuring that out, like when we went and figured that out and like wrote this, it was just the idea was to just like make that part easier for people who wanted to build different types of UIs on top of it.
Yeah, I think one component here, I mean, it's really important that there'll be an easy way to do these HTLCs on Bitcoin or Zcash. So actually, Sean Bowe, also from Zcash, he's done really amazing work in getting it, like trying to get it merged into the Bitcoin core. But say that doesn't happen, or you know, also like a component we could give here is some like simple Python API where you can do these hash time block contracts, which again are not just for XCAT. They, for example, the Lightning Network is based on them, or you know, a lot of applications.
Oh right, yeah. Sean submitted a PR to Bitcoin for just including like a hash lock contract as a basic like command line RPC functionality, which would be really cool. There's a BIP open for it.
Yeah, I really think it should be like just you can send to an address X Bitcoin or Zcash. It should be a really simple way for anybody to do a hash time block contract. I mean, it's such a basic primitive in so many things.
So next question is about this working with shielded addresses, or will it just for now work with transparent addresses on Zcash?
Right now, it just works with transparent addresses, but Ariel, I think you had a construction for the shielded addresses, and also Sean was talking about a new kind of functionality that could be added with the keys. Do you know more about that?
I don't have it clearly in my. There are all kinds of future plans. Right now, it's just transparent.
Yeah, so we don't have a clear description of how it's going to work with shielded addresses, but there is a potential for that to work. It's just not like fully mapped out yet.
There's this idea of Sean that, well, I'm not sure what is.
And whatever. Well,
there are future plans. Right now, it's just transparent.
All right. Is there any technical reason why you're using the testnet chains versus the mainnet chains today? Or is it just other than like confidence in the script or program?
I think just fear of losing money.
I also don't have Bitcoin fully synced because this depends on the full nodes.
Oh, yeah.
And like there are, like we're just using small amounts, so it doesn't even matter if we lost the money here. But I mean, yeah, there shouldn't be a risk to that. The problem is keeping them all synced, and it's faster to sync the testnet chains, I think, in my experience, and just never synced those up.
Yeah, that makes sense. So that there's a follow-up question to you mentioned that you're using full nodes. You're both running full nodes for each chain,
Yeah.
and the next step, as far as I know, is making it work without needing a full node.
Mm-hmm.
Yeah. So if you separate it, really, like what is the full node doing here? I mean, basically two things: things that involve scanning the blockchain, and a few things that involve the user's private keys. So the first type of things you can obviously do for the users. It doesn't matter if they do it themselves. Yeah. So we are working. Also, Jason Davies that was here last time may help us out with that. There is a work in progress version that doesn't require the full nodes. Basically, when you don't need the full, it's just you need, like, occasionally you need to tell the user, please put your private key, paste your private key here.
Well, you don't want to really paste your private key. Like that's what it comes down to. Is the tricky part is like key management. So.
Right. So there is a version work in progress where now you just paste the private key in the yeah, but it doesn't seem like, hopefully we'll have it in the not far future, like a version that doesn't require the full nodes and just requires you to download some, say, Python script, and that's it.
Yeah, and there's also versions that like there's a lot of different ways also to like do things without full nodes, but then it kind of, you're just moving like the point of trust around. There's like a trade-off between like convenience and actual decentralization. But so the most decentralized way is like the user still has to like manage their own keys and like maybe have the software installed, but not like have the whole chain or something. But at any rate, there are different design choices there, and we're working on one implementation of them.
So a related question, I guess, to this what are some of the biggest security issues within the process? So you mentioned if you took away the full nodes, you might risk exposing private keys in some situations. Are there any other security issues?
Security issues with the tool and protocol
with
as
the process
it
in
stands
general,
now, or with a situation in which you have a full node elsewhere and not on your own computer?
with either with the implementation now or some designs that you're thinking for the future. However you want to answer the question, I guess.
Yeah, I guess now there's so one thing that we wanted to include that we haven't yet is also like a more like a very clear one-to-one kind of parsing out of the script to let you know that like what is committed on the pay to script hash in the blockchain is actually what you agreed to. And so right now the buyer and seller kind of recalculate it for themselves to make sure that it's the terms they agreed to. But I would like to like show that visually, so the kind of the terms of the contract, so to speak, are visibly displayed. Because, for example, if your counterparty was trying to cheat you, they could give you some terms of a contract and then try to like put something on the blockchain that's different. So there's that piece. And then if you export, if you kind of outsource anything to a full node elsewhere, then there's different points of trust there. You have to trust that like they're submitting your transaction like as requested and stuff. But you get that with any sort of client where you're sending off your transactions. There's a concern about block times, like if there were like and blockchain reorganizations basically. So you would want to wait a certain number of confirmations to be sure that your transaction would be included and stuff like that.
Well, also potentially, I think also Jason mentioned this to me. There's like a potential of kind of a denial of service attack that a lot of people, bots or something, say to you, hey, we want to do an XCAT with you, you start. So you lock your money and then they just run away. And so, you'll get your money refunded, but there's all this time where a lot of your money is, or a lot of people's money is locked. So that's, I think, kind of an inherent, and so you could maybe have some sort of reputation system where if someone does this aborting, then he loses his reputation, and yeah, so that's like one aspect. Like the locks are one aspect that can, it's a small disadvantage.
Yeah, like the time opportunity cost of your money and like the exchange rate during that time.
Mm-hmm. That makes sense.
Yeah, I think also Jason mentioned to me this idea of a reputation, like building a reputation system, so people who abort a lot, no one deals with them.
So a simple question: how many transactions are there for each blockchain?
You mean how many have been done, or?
During one XCAT trade, how many transactions happen on each blockchain?
Oh, 2. You have the fund and then the redeem, basically.
Cool. And where do people find the GitHub repo for the XCAT project?
So we were going to open it up this week, but we still need to have a meeting and talk through some stuff. So when it is released, it will be Zcash/ZBXCAT. But we'll write a blog post about it and release it soon.
Yeah,
we'll just try that address every 10 minutes. And...
Yeah, we intend to I think like the blog post that's in a draft form right now is kind of intended to come out in the very near future, which will talk about the kind of future plans in more detail of XCAT. Let's see. Oh, and we have a question about Ethereum. How will this work with Ethereum as well?
Yeah.
So actually, we were we were in this Ethereum hackathon, and that's exactly what we worked on. So
yeah, we did it differently though. So we wouldn't use like the same kind of command line tool, I think, because of Ethereum's smart contract functionality. So what we did there was we had a smart contract to manage the trade information stuff, and then had a kind of decentralized application that would call out to that to populate the data and execute the trades. Oh, and we ended up using MetaMask to kind of submit the trades to the Ethereum blockchain, which is a really cool idea of how you could do this without full nodes, for example, like have a web client like MetaMask kind of format your transactions and send them off. It'd be cool if we had that for Zcash.
Yeah, but basically it's easier for Ethereum because just you have these much more convenient tools, the smart contracts and.
And is that like something that you'll work on more after the Bitcoin implementation is done, or are you kind of leaving that up to other people to dig into?
Not sure what the plans are, but we definitely should work on it more. I'd like to go back and make the demo app we made kind of more usable, because what we ended up with at the end of this week-long IC3 hackathon was a little web app that actually did work to execute trades on testnet between Zcash and Ethereum. It just wasn't very robust or usable for real users. So we could polish that up eventually.
And a kind of a related question, would this work for other tokens on Ethereum that are based on Ethereum?
Well, you mean between Zcash and other tokens, or?
Yeah, like Ethereum-based ICO type tokens.
I think, yeah, because writing this hash time block contract on Ethereum is very simple. So yeah, it should be very simple to do it with any ERC token.
I don't see why you would do it like this because Ethereum tokens are also on Ethereum, and you could just manage the trading of that in some other way. I think because
no, but if it's between Zcash, if it's between two of these tokens, then yeah, you would.
Right.
But if
okay, yeah, definitely. This is the only reason that this sort of hash time lock construction exists is because of the way the scripting languages work. And so, yeah, interfacing with Ethereum or any other thing, as long as you're dealing with a cryptocurrency like Bitcoin or Zcash, you kind of need this. But then with other sort of blockchains, probably not.
Nice. So I don't see any more questions. There was actually, I'll post the chat transcripts to the description afterwards, but there's actually some collaboration already happening about like implementing a UI and stuff. So
Cool.
That's really cool to see.
Awesome.
Yeah, I wanna maybe say it should, like any Bitcoin clone, any coin that supports the Bitcoin scripting language, or between any two of those, it should require, even this code should work with not large modifications.
Yeah, you could like Litecoin would be like easy to change stuff to support.
Well, actually, there's a kind of a more general question that might be interesting for you to answer. How did you both get involved and interested in Zcash?
I mean, Ariel's an awesome ZK Snark cryptographer. And I was kind of working in the cryptocurrency space and really admired the work that Zcash was doing. I was working on different kinds of applications of blockchain tech, but I wanted to actually work on like a cryptocurrency itself.
Yeah, for me, I mean, I was doing just theoretical computer science for many years. And when I understood Bitcoin, when I read the Bitcoin white paper, I was like, like many people, I was like, wow, this is the thing. This is like, that's what got me into cryptography. I wasn't too much into cryptography before that. And yeah, so for me, like it's kind of the perfect combination of theory and practice, something I looked for a long time. It's also like the whole cryptocurrency space. It's like kind of a playground for a lot of ideas or concepts that were only in theoretical computer science. Like the zero knowledge proofs and this cryptocurrency space. It's what's kind of letting these things come from theoretical computer science into the applied world. I kind of even think of it sometimes, it's like, a cartoon character that comes from the cartoon into real life. That's how I kind of feel with these ZK snarks. Like they were in these fantasies and cartoons, and suddenly with the cryptocurrency space and Zcash, you see them suddenly in real life instead of in a cartoon.
That's a really good analogy. Great. Well, thank you both very much. I think this was our most popular show and tell yet. So hopefully we can build on this momentum and feature more really cool things that are happening with Zcash in the community. So unless you have any final words, I will stop the broadcast and yeah, we'll end it.
Oh, I guess the final word would be if people are working on user interfaces or implementations, it would be great to know what kind of interfaces they would like. Because I think we've been kind of trying to hypothesize what people would want to build. But if people are actually working on stuff, they should go to our community chat and maybe go to the Alchemy channel and let us know what kind of like API calls or what kind of interfaces would be more helpful for them for what they want to build on it.
Great, and that's a good point in general. We can list kind of the resources that are surrounding this whole project in the description in the YouTube video, so you can check there for all that stuff. All right, thanks, and we'll be back sometime in the future with another show and tell. Bye.
Bye. Thanks.
Thanks. Bye.